Hey guys, welcome back. In today's video, we'll be diving into one of the most powerful concepts in programming, which is recursion. We'll learn what recursion is, how it works, and where it can be useful. We'll also go through examples, including the classic factorial function. So let's get started. Now, what is recursion? Recursion is when a function calls itself either directly or indirectly as part of its execution. Now, in simple terms, recursion is a technique where a function repeats its process by calling itself until a certain condition is met. And this condition is known as the base case. So, until the base case is satisfied, the function will keep calling itself. Now, due to this, we run the risk of the function calling itself indefinitely. So, what will happen here is we might run into an infinite loop, and this can cause our program to crash because of a condition known as stack overflow. Now, what happens is whenever we call a function, the function is pushed onto the stack along with its variables and the return addresses. Now, if we keep calling the function indefinitely, what will happen here is at one time the stack will get full and we will not have any space on our stack to push more functions. So this is known as stack overflow. And we should be cautious about this when using recursion in programming. Now let us see the structure of a recursive function. Now structure for recursive function is pretty simple. So first we will just define a function how we do normally. Void, let's call this recursive function. And first thing what we'll do here is we will give a base condition. Okay, base case condition to stop recursion. Now this can be any condition. I will put it in a if block. I will write some condition here. And if the condition is satisfied, it will return. Okay, it will return some value. We'll see this with the help of an example in which we'll learn how to get the factorial of a number. And then in the same function, the function will call itself. In the same function, it will call itself and then we'll close the block. So as you can see here, in this function, what I have done is I've created a base condition that will stop the recursion and I'm calling the function itself. Now the base case is responsible for stopping the execution or the function from calling itself once the condition is met. And the recursive call is where the function calls itself with updated parameters, okay, moving closer to the base case. So let's see this with the example of a factorial. Now factorial of a number basically, as we know in mathematics, represented as n factorial or the exclamation mark. Now what will happen here is it is basically the product of all possible integers, positive integers from 1 up to n. For example, if I take the factorial of 5, it will give me 5 into 4 into 3 into 2 into 1. That is basically 5 into 4 factorial, or 5 into 4 into 3 factorial, or 5 into 4 into 3 into 2 factorial. And once we reach 0 factorial, the value of 0 factorial is 1. So this is the base condition which will be satisfying here, that when n is equal to 0, we will return the value 1. So let's go ahead and implement this. So include stdio.h, my header file. Then here I will have my recursive function. This will take the number n and it will find the factorial of that. Now how long until where it will find the factorial? It will find the factorial until n is equal to 0. This will be my base case which has to be satisfied. And once n is equal to 0, I will return 1 because we know that the factorial of 0 is 1. And then again I will call the function return n into factorial of n minus 1, as we have seen in the formula of recursion, how to find the factorial. Okay, sorry, I mean the formula of factorial. How can we find a factorial of a number? Let's go ahead, implement this. We will call this function in the main function. I will give a number, let's say 5. We want to find the factorial of 5, and I will print the factorial of 5. Okay, and here is where I will call my recursive function. Factorial of number. So let's go ahead and run this. So as you can see, the factorial of 5 is 120. Okay, so this is how we can find a factorial of a number by using recursion. Now let us look at some common mistakes when using recursion. Like I said, recursion is really powerful, but it has its own risk. If a function's base case, that is the base condition, is missing or unreachable, the program will go into an infinite loop, and at one point it will cause a stack overflow. That is, my stack will be full and I will have no space remaining on the stack. Now, one thing we need to make sure is always double check that the base case is achievable, and each recursive call should move closer to that base case. This is how we can avoid going into an infinite loop. So let's see what happens if we don't mention the base case here. What if so? Okay, so I'll go ahead, I'll remove the base case or the base condition and run this program. As you can see, my VS code has got stuck. Okay, and I didn't get any output. So this is because my program run into an infinite loop. Okay, I didn't get the proper output. So this is what happens when we don't give the base case in recursion. Now let's go ahead and see what are the advantages and disadvantages of using recursion. Now, recursion basically simplifies code for complex problems, as we saw in the case of factorials, Fibonacci series, and tree. Also, we can use it in tree traversal, which is one of the main operations when dealing with tree data structures. In this case, recursion is used a lot. Now, recursion provides a natural way to express repetitive tasks with varying input. But a main disadvantage of recursion is that it can lead to high memory usage due to multiple function calls being stored in the stack. Like I said, if the base condition is a bit impossible or difficult to be achieved, this will cause a stack overflow or a program running into an infinite loop. And sometimes it may be less efficient than iterative solutions for simple problems. Now we will see this in detail when dealing with data structures, how recursion is used. Okay, so recursion is best for tasks that break down into smaller similar tasks like mathematical sequences or data structures with branching such as tree. So just a quick recap to wrap it up, recursion allows functions to call themselves, making them ideal for repetitive tasks with changing inputs. And to remember some key points is that a base case is required to stop the recursion and a recursive call to break down the problem. While recursion can simplify your code, it is important to use it carefully due to memory concerns. So that's it for today on recursion. If you found this video helpful, give a thumbs up, subscribe for more C programming content, and let me know in the comments what other topics you'd like to see. Thanks for watching and see you next time.